And then you end up with plus 8 minus 6x squared. Is that true?
Yeah.
So you end up with x squared plus 6x plus 9 plus 64 minus what, 96x plus 36x squared? Is that true?
Yeah.
We can still clean it up a little bit. So how many x squares do we have? 37 of them? Right?
Yeah.
How many x's do we have? Minus 90x plus 73? What power is that? Plus 73 to the 1/2. So we find d prime. We end up with 1/2 37x squared minus 90 all to the times what? Oh, sorry. Got to keep them inside. Was mixing the chain rule with everything else. Times what? 74x minus 90, right? What does that equal? That's 74x minus 90 over 2 times the square root of 37x squared minus 90x plus. And you're interested in when that's equal to? You're interested in solving this equation right here, right? What's the only way to make a fraction equal to 0? Numerator equals 0, so 74x has to equal 90, so x is equal to 90 over 74, which is 45 over 37. What does remember what the original question asked? I think it was asking for a point, right? Was it asking for a point? Find the point on the line 6x plus y equals 9. So we know that 6x plus y is equal to 9. We're not done yet because we have an x value. Is an x value a point? No. So you have 6, 45 over 37 plus y is equal to 9. And who has the answer to this? I don't really want to think about it. Y equals what? What? 63 over what? 37? So the final answer would be 45 over 37, comma, 63 over 37. There it is, right there. Good. That's it. What should you do first? What? None of you started this question? The distance formula. That's a noun, so give me a verb. You want the distance between 1, 0 and xy. Some point. What's the distance between those 2 points? The distance between those 2 points in terms of x and y is going to be what? The square root of what? X minus 1 squared plus y minus 0 squared. So this is the distance formula right here. You end up with the square root of x minus 1 squared plus. This is what you are trying to minimize or maximize. You're trying to maximize this, but what constraint do you have to abide by? What other relationship does x and y have to hold? 4x squared plus y squared has to equal 4. What does y squared equal? So where can you put that? You take this, you plug it in right there, and what do you end up with? dxy, and it's not going to be dxy anymore. It's not in terms of x and y. What's it in terms of? Just x. It's going to be 4 minus 4x squared. Thank you. Yes. So it's x minus 1 squared plus 4 minus 4x squared. What should I do at this point? Simplify. D in terms of x is going to be x squared minus 2x plus 1 plus 4 minus 4x squared. How many x squareds do I see there? Negative 3 of them. Not negative x, negative 3x squared minus what? Plus, you have the square root of that. Now what do you take? The derivative, d prime of x is going to be 1/2 times negative 3x squared minus 2x plus 5 to the times 6x minus. You have to make this equal to 0. What's the only way to make a fraction equal to 0? Numerator, so negative 6x minus 2 has to be. So x is going to be equal to, so negative 6x equal to positive 2. So x is equal to Negative 1/3. So if x is equal to negative 1/3, how do you figure out what the other point is? Yeah, you know that 4x squared plus y squared is going to be equal to what? 4. X is equal to negative 1/3. So 4 times 1/9 plus y squared is equal to 4. You know that. So y squared is going to be equal to what? 32/9. Is that correct? Right? 4 times 9 is 36. 36 minus 4 is 32. So what does y equal? Tell me what y equals. Plus or minus the square root of 32 over 3. So you can say plus or minus root 32 over. Can you break down 32?
Yes.
4 root 2. Yeah. So it's plus or minus 4 root 2 over 3. So how many points are there on this? There's 2 of them. There's 1/3 comma 4 root 2 over 3. And what else? And 1/3 comma 4 root 2 over 3. There it is.
Why do we take the derivative?
Okay, so what did you do first? What's a great first step?
Draw it.
Draw it. Let's draw this picture. So you have a box. And what does it not have? A top. So you have x, y, and it's a height. Great. A box with a square base. Oh, it's a square base, so it's not x and y. What's it going to be? X and a height of y. Must have a volume of 32,000 centimeters cubed. So you know the volume in terms of x and y must be x squared times y. But what must that equal? 32,000. So did everybody get that equation right there? Is that our constraint or what we're trying to minimize or maximize?
That's a constraint.
That's the constraint. It's telling you the relationship between x and y. So now, find the dimensions of the box that minimize the amount of material used. So you need to write an equation for the what? No, we already have the volume. The material used. Use the phrases that are in the problem. The area of the surface area. So what's the surface area of this going to be? The surface area in terms of x and y is going to be what? X squared plus 4 what? 4xy. This right here is what we were trying to optimize. This one right here. Are we trying to find the minimum or maximum surface area? Minimum. We want the minimum. How many variables are in this?
2.
We don't like that, do we? Is this multivariable calculus? No, this is not multivariable calculus. So we need to make it into single variable. When I ask questions, it's good to answer them. So how do we do that? We have a relationship. How do we write it as a single variable? Solve for y, yeah. What does y equal? Over x squared. And where do we plug that in? Exactly. So you get s in terms of x is going to be x squared plus 4x times what? What should we do first before we do anything else? Yeah, cancel an x. Thank you. So what does that turn into? 4 times 32,000 all over x. And another way to write that, because we know, what are we going to eventually have to do to this? We're eventually going to have to differentiate. So I like turning it into 4 times 32,000 times what? Exactly. This is the function we are trying to minimize. Hopefully it's going to go down then up. So we're looking for the point where the derivative is... Could there be more than one? Sure, there could be more than one. There might be more than one. So what are we going to take? We're setting to take the derivative. Someone tell me what the derivative is going to be? Plus, or minus, sorry. Minus 4 times 32,000 to the negative 2. Is that correct? And we're setting this equal to 0. You're going to do this. Remember what I think I told you this already. If you're ever lost on a question, what should you do? It literally will be helpful in probably 50% of the problems you look at. You will do that in probably 50% of the math you do in this class. And then sometimes it might not help you, but at least maybe got you doing something. So what do you end up with? You end up with, you know, that 2x has to equal 4 times 32,000 all over what? X squared. Yes?
I got stuck because I didn't...
So what do you end up with? 2x equals 4 times 32,000. You know, so I didn't multiply it out yet. So what does x cubed equal? 2 times 32,000, which is 64,000, which should make you happy. Whenever you get something like this, you should be happy. Why? It's a really nice cube. So what does x equal? 40. So what does y must equal? 20. Because you know the base has to be 40 by 40. And how do we know that y is equal to 20? Well, we know that x squared times y has to be 32,000, right? So we know that 1,600 times y is equal to 32,000. So y is equal to 20. So we know that this box is 40 by 40 by... What's the one thing we haven't done here? We haven't done what? We didn't verify. Let's actually verify this one right here. Where's the derivative? You see this derivative? In order to verify, we can do the first derivative test, which is to show it's going negative and then positive. The first derivative. I don't really want to do the first derivative. I want to do the second derivative test. For it to be a minimum, what's the concavity have to be?
Down.
Come on. What am I doing here?
Up.
Concave up.
Up.
Concave. Echoing the answer. That's good. I like that. So let's find the second derivative here. What's the second derivative of this going to be? What's the second derivative of this? 2 plus 8 times 32,000 x to the what? Negative 3. So we got an x value here of 40, right? S double prime of 40. If you look at that, is that going to be positive or negative? It's going to be 2 plus 8 times 32,000 all over 40 to the third. Is that positive or negative? It's positive, so must be what? Must be concave up, so it's a minimum. So did we just verify it? You have to make a judgment call. You can do the first derivative test, which is plug in something to the left and right. Or if the second derivative is really easy to find and evaluate, if the second derivative is really easy to find and evaluate, use the second derivative test right there. Okay, let's do a little more step. What do you do? Draw a picture. Oh, thank you for saying that. Oh, it was great that everybody said that. Box with a square base, so it's x, x, and y. Nice. So, 1,200 centimeters of material is available to make a box with a square base and an open top. So what's the surface area going to be? You just used this. And what's the volume going to be in terms of x, y? X squared y. And we know that the surface area has to equal what? 12,000. 12K. Great. So which one are we trying to minimize? Oh, we're trying to maximize. Sorry, maximize it, right? So find the largest possible. That's in two variables. We want it in. So what are we going to isolate in the first one? So what does y equal? 12,000 minus x squared all over what? 12,000 minus x squared over 4x. Great. Where do we plug that in? Right there. 1,200? Oh, it's 1,200, not 12,000. That would be, so it's 1,200. 1,200. Thank you. So it's not this, it's 1,200. Good catch. So where do we plug this in now, Carter? What do? We plug it in? Plug it into the volume. And now what do we have that's so useful? We have the volume just in terms of Carter. So what's it equal? X squared times 1,200 minus x squared all over. What should I do first before I do anything to this? Cancel an x. So volume in terms of x is going to be 1,200x minus x cubed all over, which is the same thing as 300x minus 1/4 x cubed. Is that correct?
Yeah.
Do we agree? So what do I do with this now? What do I find now? Differentiate. 300 minus 3/4 what? X squared. So you know that we want this to equal 0. So 300 has to equal 3/4 x squared. So what does x squared have to equal? 1,200 over 3, which is 400. So what does x squared have to be? Plus or minus 20. But we want x is a distance, so which one do we want? Positive. So x is equal to 20. It's 20 by 20. So now we know, we know that x squared y has to, sorry, excuse me. How do we find y? We know y is equal to 1200 minus x squared all over. 1200 minus x squared over what? So y when x is 20 is going to be 1200 minus 400 all over 80. So that's what? 800 over. So y is equal to 10. So we know that this box is 20 by 20 by 10. And what haven't we done yet? We haven't verified. We're not going to verify it this time. You could verify using the second or first derivative tests. In this case, similarly, it would be nice to use the second derivative. Hey? Piece of wire. How long is this piece of wire? 10 meters. And how many pieces am I breaking it into? 2. And what do we know x plus y is? There's your relationship right there. Which piece, x or y, is going to be the square? Well, it doesn't matter, so you have to decide. Okay, this is where the differences are going to start because you're going to do y for square. Let's just do x square, okay? So x turns into the square, and y turns into the triangle. So you have a total of x meters of wire, and you have a total of y meters of wire for the triangle. We're trying to maximize area, or what? Are we trying to maximize area? Yeah, the volume. Well, not volume, area here. So if the total thing around this, what's the side of each of those? What's the side length? 1/4 x. 1/4 x. So what's the volume here going to be? 1/4 x. What's the area of this box going to be? X over 4 squared. Equilateral triangle here, what's the side length of each one? Y over 3. Y over 3. Y over, oh not 3, y over 3. You need to write the area of this in terms of just y over 3, right? Just y?
Y over 6.
Yes, but do we have the height?
Well, yeah, we do.
1/2 of that times 3.
Okay. There also is just a formula for this, which is what you're determining, really, right?
Yeah.
You're using 1/2 base times height, but you're trying to find this height, correct? You're trying to find this height right here. What is that height going to be?
Root 3y over 6.
Root 3y over 6. Do people agree with that? So which one is it? How do you figure it out? You know that h squared plus y squared over 9 has to equal y squared over 36 has to equal y squared over 9. Where did I get that from? If this is h, if that's the height right here, kids, if this is the height right here, h squared plus half of this. What's half of y over 6? Is equal to y over 3 squared, right? So what does h squared equal? It's going to be y squared over what? 6. No, not 4. So it's going to be, we have to multiply by 4, right? 4y squared over what? I'll write it out even further. It's fine. Y squared over 9 minus y squared over 36. If we need to add fractions, what do we do? It's common denominator, right? So 3y squared over. So it's going to be y squared over 12. And this is h squared, right? So what's h going to be? Y over? Why not the negative? Can't have a negative distance, right? So which is equal to, yeah, you just leave it like this. This is fine, okay? So what's the area of that triangle going to be? 1/2. What's the base? Times the y over root 12. So what's the area there going to be? Y squared over what? Y squared over 6 root 12. What is root 12? It's 2 root 3. So what does that equal to? Y squared over 12 root 3. We can leave it like that. That's fine. So up here we know that the area of this one is going to be y squared over what? 12 root 3. So what's the in total volume in terms of x going to be? X over 4 squared plus y squared over 12 root 3. That's nice, but how many variables are there? We need to write it in. So what do we isolate right here? Y equals 10 minus x. So what do we have here? We have volume in terms of x is equal to x squared over 4 plus 10 minus x squared all over 12 root 3. Nice! We have one variable in here. 1. What can we now take? You can. You don't really have to. Well, yeah, you can, or I mean, this is just a coefficient, right? So we can just do the derivative of the top and just bring that along for the coefficient. So what's v prime going to be? 2x over 4. Nope, it's just 1/4 times the derivative of x squared, right? Plus what? 2 times 10 minus x to the what power? Times what? -1, right? So we now have x over 2 plus, or sorry, not plus what? Minus, right? Minus 10 minus x all over 6 root 3 equals 0 right here. What did I do there? I canceled the 2. Does everybody see how I canceled the 2? And do you notice how I kept the parentheses around the 10 minus x? So now can you solve this? Sure, you can solve this. Keep going. Are you kind of home free at this point? What's the hardest thing to build generally? The equation right here. This right here, when you get here, you should be pretty happy. What's also nice about this is, can you take the derivative decently? Can you get the derivative of this? Yeah. Is it impossible? No, you can do it. You can definitely do it. Minimum. Thank you. So when it says left bound, where do you bring this cursor? To the left of where it is, and it's kind of hard to see right here. But let's go really far, all the way to here, and we press, oh, look at this. Press enter, and our right bound, do you see the cursor as it's moving? Let's make sure it's all the way to the right, and then we'll make our guess. It's somewhere in here, right? Yay. Minimum right there. So there it is, right there. There's our minimum. So our minimum is this. So that means we need this much goes into the square. How do we figure out how much is for the square? For the triangle, I mean. Yeah, it's just going to be 10 minus 1.61390057 is equal to triangle wire, right? That's how you get it right there. Now I have a question for you. If I said, sometimes you're going to have interesting questions where you're going to have a limit on the domain. We did this over and over again. We looked for absolute minimums and maximums, right? You have to test the critical values and the what? Endpoints. So in this case, this is a end. What if you forget to test the endpoint sometimes? You're not going to get the wrong answer, right? If I asked you right here, something let's unrelated. Let's say I gave you a picture right here of this graph right here, and I asked you right here. Let's say I asked you to go from the minimum from there to there. Where are the absolute mins and maxes? Well, you might say, hey, oh, here's the max and here's the min. Is that correct? No, this would be the min and this would be the max because they're slightly higher and slightly lower. So what's the lesson here? Don't forget to check what? Endpoints. Okay, so your homework here is type of all work for quiz. We just finished this question right there, so you don't need to finish that one. And I'm going to give you a couple more to do here. Let's do this.